Okay, so now that we've learned how to simplify radicals, now we have to talk about adding and subtracting radicals. So before we do that, just recall that when you have two terms, they have to be the same term in order to add them. So x plus x is 2x. 2ab plus 4ab would equal 6ab. So we need to make sure that the coefficients can be different, but the variables must be the same in order to add. And the same is true for radicals. So if we look at example 1, we have to make sure that only like radicals are here. So we do have like radicals. We have square root 5 on each of these terms. So we can say we have 5 root 5 plus 2 root 5, which is 7 root 5. Take away 3 root 5, which is equal to 4 square root 5. Okay, so if you think of the radical as a variable or as the number of things you're adding and the coefficients as how many you have, then you can add them together or subtract them simply. For b, notice we have a constant and a constant. Those two are like terms, and so they must go together. And then we also have square root 11 and square root 11 on each of those terms, and so those must go together. So we have negative 5 root 11 plus 9 root 11. So altogether we have 4 root 11. And then 7 take away 9 is negative 2. Okay, now what happens when the roots are not the same? We can't just assume that they're incompatible and we can't add or subtract them. We have to see if we can simplify and then end up with a like radical. So the cube root of 16, if I think of all my perfect cubes, I know that 2 cubed is 8. So I can rewrite this as 8 times 2. And the cube root of 54, I can think of my perfect cubes, and I think that 27 times 2 gives me 54. So I have a perfect cube and I have a perfect cube. And again, if it helps you to write your perfect cubes down the side and your perfect squares before you write your test, that would be a very good idea. So the cube root of 8 is 2, and I'm left with the cube root of 2, plus the cube root of 27 is 3, and I'm left with the cube root of 2. And now we have two like terms that have square root 2 as their commonality. So I have 2 of them plus 3 more, so my final answer would be 5 cube root 2. Okay, so in D, the 7 kind of gives us a hint as to what our common root will be. But let's go ahead and try. So 8 root 7 minus 2 times the square root of 28. Now 28 is 4 times 7, or 7 times 4. And if we simplify further, well, the square root of 4 is 2, so I have a 2 outside already, and then I take the square root of 4, which is 2, and I have root 7 left over. So I have 8 square root 7 minus 4 square root 7, so my final answer is 4 square root 7. Okay. I'm going to let you try E and G by yourself, and we'll go over in class. F, we have a number of terms, so let's see. 4 square root 3 can't be simplified any further. 20 would be 4 times 5, because the only things that multiply to 20 are 4 times 5 and 20 times 1, and 4 is a perfect square, so that's a better choice. Square root 12, I believe, is also 4 times 3, and the square root of 45 would be 9 times 5. Okay? And at any time in this video, you can pause and try these before playing, just to see if you're on the right track. Okay, so let's simplify. We have 4 square root 3 plus 3, and I'm going to take the square root of 4, which is 2, leaving the square root 5 inside. And then I have 2, taking the square root of 4 again, which is 2, leaving the square root of 3. And finally, the square root of 9 would be 3, leaving the square root of 5. So now let's go ahead and group like terms. So I have a square root 3 here and a square root 3 here, and I'm going to put them together. So I have 4 square root 3 take away 2 times 2, which is also 4. So I have 4 square root 3 take away 4 square root 3. So actually I have no square root 3's left over. And then I have 6 root 5 plus 3 root 5. So my final answer would be 9 square root 5. Okay. Last but not least, we have a cube root. So again, we need to think of a number that multiplies 3 times into 250, and there will be a leftover. So let's think. We have 6 cube root, and because it's 250, I automatically think 5. Does 5, what's the cube root of 5? So 5 times 5 times 5 is 125. And then I still need to make 250, so I think it's 125 times 2. And our second cube root, we have a cube root of 500. So take a minute and think, which of my cube roots will multiply to 500? Okay, and so I still think it's 125, but in this case we need to multiply it by 4. So in the first one we have 6, and the cube root of 125 is 5, cube root 2, minus 5, well, the cube root of 125 is 5, and don't be tempted to take the square root of 4, because we're not square rooting this, we're cube rooting it. So as tempting as it is, we cannot simplify the cube root of 4 any further. So our final answer would be 30 cube root 2 minus 25 cube root 4. And we can't combine those because these are not like radicals. Okay, so now let's talk about what happens when you have you have variables underneath the radical. Because we know with square roots, and this is a recall with square roots, we cannot take the square root of a negative number, is not allowed. Can't take the square root of any negative number. Because when you think about what a square root means, it means that you've taken the same number times itself to get, and you always end up with a positive. So we cannot take the square root of negative numbers. So when we're talking about variables, sometimes there are restrictions on what they can actually equal. So if we take a look at the first one, we have the square root of x to the 7. So I want to think about this like this. Let's draw a little number line. I have 0 here, and let's take a number on the right hand of 0. Let's take the number 1. If I plug 1 in for 7, I'll have the square root of a positive number, which is fine. But if I take negative 1 and I plug it in for 7, or in for x, well, negative 1 times negative 1 times negative 1 times negative 7 times will still give me a negative number. So what I would have to say is x has to be greater than 0, right? It has to be on this side only. But can it equal 0? Yes, it can, because the square root of 0 is just 0. So x has to be greater than or equal to 0. So let's talk about b. Again, draw a little number line, put 0. And if we take 1 and plug it in for x, well, 1 to the power of 6 is still a positive number, so that is okay. But if I take negative 1 and plug it in, well, negative 1 to the power of 6 is also positive. So no matter if I take a positive number or a negative number, and again, I could have taken any positive, I could have taken 100 to the power of 6 or negative 100 to the power of 6. Either way, I'm still going to positive. So what we say is x is an element of all real numbers. X can equal any number. No matter what we substitute in for x, we will always get a positive. So now let's talk about c, because this one's a little special. So if we take positive 1, and again, it could be any positive number, and we plug it in for b, we get 1 to the power of 5, right? 1 to the power of 5, but it's being multiplied by -3. So actually, now we will get a negative value if we plug in a positive number. If we plug in a negative number, say -1, we will get -1 to the power of 5. So that means you're having 5 -1s multiplied. So I end up with a negative times another negative. So -1 times -3, which will give me a positive. So in this case, we have to choose any numbers that are below 0. So we say x has to be less than or equal to 0. So just be very careful. We can't assume that just because it's a square root, it has to be bigger than 0. We have to double check and see what else is underneath the square root. Okay, so in D, again, draw your number line. If we plug in 1 into y, we will get a positive number. But take a look at the root. It is a cube root. The cube root of a negative number is allowed. Same with a fifth root of a negative number. So we can go ahead and say, okay, well, for any cube root, fifth root, we can automatically say that it's an element of all real numbers. So make sure you use the right variable, y-e-r, m-e-r, x-e-r, y-e-r, z-e-r, because in H there's 3 different variables. So it's nice when you see a question that is an odd root, like a cube root, fifth root, seventh root, etc., because you can automatically say, well, my variables can equal any number we want. Okay, so let's skip to E. So we have the fourth root, it's an even root, of b to the 7. So if we plug in a positive number, let's say 1, we have 1 to the power of 7, which is positive. If we plug in -1, -1 to the power of 7 is a negative number. We are not allowed to take the negative fourth root. So we have to say that x is anywhere from 0 onwards. So x is greater than or equal to 0. Now f has 2 variables. So a, I can already see is squared. That means no matter what I put in for a, it'll always be positive. So a-e-r. But b, let's just check b. So if I plug in 1 into b, I will get a positive. And if I plug in -1, I will get a negative. So that means b has to be greater than or equal to 0. Okay, I only want positives underneath the square root. All right, and then last but not least, we have -r cubed s6. And it's a fourth root, so we do need to be careful what each of those are. So if we look at r first, if I take +1 and I plug it in for r, I get 1 to the power of 3, which is positive, but there's a negative in front. So actually it becomes negative on this side. If I take -1 and I plug it in for r, I get -1 cubed, which is negative, with a negative in front. So this becomes positive. So what we can say is that r has to be less than or equal to 0. It has to be this side of the number line. It has to be anything smaller than 0. Now s is an even power. That means no matter what number we plug in for s, it will always be positive. So we can say s-e-r. Okay? And that's the end of the lesson.